Problem solving using energy. This is a very, only a limited number of slides, but it's a very important part of this unit. We start out by saying this little knot here, that means initial or the starting. So the starting energy will equal the final energy in a mass spring system. The energy is constant, right? At any one point, the total energy we already mentioned is a combination of kinetic energy and elastic potential energy, those two types of energy. So what we could say is we're starting with an initial EPE and an initial KE, and we're ending with a final EPE and a final velocity, a final kinetic energy. So here's our problem. What's the total energy? So we're looking for total energy, and energy is measured in units joules, we mentioned that before, of a mass spring system if the mass, let's write that given down, is 2 kilograms. And the spring constant, that's that K value, is 200 Newton meters. And the amplitude of oscillation is 3 meters. That means how far it's stretched, which is X, 3 meters. So we can go back and say, okay, the total energy of a system, spring system, is going to be the kinetic energy plus the elastic potential energy. Now they told us the amplitude of oscillation, which means it's the maximum amount this mass spring can be stretched. It's stretching that spring as far as it possibly can. When it stretches that spring as far as it possibly can, it has a tremendous EPE, right? That spring wants to snap back as badly as it can, so there's a tremendous force. But the velocity is 0 at that point, which means it has no kinetic energy. So the total energy of this system is literally all EPE. So we can solve that by putting in 1/2 kx squared, substituting in our values, and we're going to get 900 joules. What's the maximum velocity in the mass spring from the previous slide? So now they want to know, so all right, so we have a total spring energy, right? Yeah, so we said the EPE was equal to 900 joules. And they want to know what's the maximum velocity. So when it's 900 joules, the spring is completely stretched, and that's equaling the total energy of the system. So once again, E total is going to be equal to kinetic energy plus EPE. And now we said the total energy is 900 joules, and they want to know the maximum velocity. So the maximum velocity is when it's crossing the equilibrium point at x equals 0. When that mass is crossing the equilibrium point, it's not stretching the spring anymore, and it hasn't compressed the spring, which means it has no more EPE. So we have E top equals 1/2 mv squared. Now what we need to do is solve for, and this is actually V max, maximum velocity. So to solve for velocity, the first thing we have to do is multiply both sides by 2. That gets rid of the 1/2. So we have 2 E top equals mv max squared. Well, we don't want mv max squared. V max squared is multiplied by m, so we can divide by mass. Now we have v squared equals 2 E tot over mass. Well, we don't want v squared, we want v, so we could take the square root of both sides. And now we're going to have velocity equals 2 times E tot over mass. So 2 times, and our total energy, we said, was 900. And our mass they gave us was 2. whoops, let's see, forgot the square root sign. So the 2's will cancel, and we're left with square root of 900, which is 30 meters per second.